Okay, so I'll quickly start recording. So we discussed about the name node. Name node contains just the list of blocks for each file, list of data nodes for each block, attributes like when was file created and all those things. It does not contain your real data. I hope you remember this thing, right?
Yes.
Okay, and then it contains the transaction logs, when was the file, basically file creation time, deletion times, and all those things. Uh, so this I just want him to join to explain this slide. Shekhar, you can see the screen now? Okay, cool. So I hope you remember main node contains just the list of files, the metadata about the data, not the real data, and the real data is stored on data nodes. It contains your things like which block is associated to which file, the files are there, which files are there in the system, and all those things. And let's talk about the H high availability cluster, that is Hadoop 2.x architecture, where we don't have a secondary name node. So although this slide I normally cover in the yarn architecture, but I think I use this slide for some purpose over here. So let's discuss this slide over here only. So what happens in high availability cluster, that is Hadoop 2.x architecture. In 1.x we don't have a high availability cluster. We have to manually, if the name node goes down, we have to manually start the secondary name node, and that's where the manual intervention is required. However, in the 2.x architecture, there is no manual intervention which is required, and all the cluster is made highly available with the help of Zookeeper. So what happens up is, there are two machines configured as name node. There's nothing like primary or secondary name node, or both of them are name node. Only the thing is, one is active at a time, another one is passive. So at any point of time, one of the name node is active and second one is standby state, or we can call it passive. The active name node is responsible for all the work done in the cluster. That's what our current name node does up, and all the activities of the name node are done only and only by the active name node. However, the passive or the standby node keeps on synchronizing its state from the active name node. So there is a communication between both of them with the help of background threads called daemon threads, and the standby nodes keeps itself updated to the state where your name node is. When any namespace modification are performed by the active name nodes, the logs are sent to from these daemon threads to this standby node. So the standby nodes, the current state, or basically it's in the same state where the name node is. Standby nodes keep on reading this and keeps on updating its state. In the event of failure, standby will ensure that it has read all the edits from the general nodes and before performing any updates in it, and the active node will basically go down, and the standby node will become active. And one more thing which happens at the backend is the data nodes also. So basically, what happens in the cluster is data nodes also send the information about um, whether they are up or not. So there's a heartbeat signal which are sent from data nodes to the name node periodically. By that way, the name node knows that the data node is up and running. Otherwise, if the heartbeat signal from the data node does not reach the name node in a predefined frequency, in that case, name node safely assumes the data node is down. Also, data nodes keep on sending basically the state of blocks they have. So in this HA high availability cluster, data nodes send their information not only to the active node but also to the standby node. So at the end, when the active node goes down, standby node have all that information also, other than the information which is passed from the name node. So that's a way standby node is always in a state which is equivalent to name node, and when name node goes down, the write permission on these general nodes is given to the standby node, and read permission is given to the name node. So basically vice versa happens, and is the active name node in that case, the X active node in that case will not be able to read those, write to those general nodes. So does that make sense, or shall I repeat the whole thing?
Is there any like any chance where uh, there is a data loss?
No. So that's the reason. If you see over here, what happens is, if you see over here, uh, so this is step ensures that there is no data loss. It will read all the data which is committed or basically logged to the threads, the daemon threads, before making itself up. So whatsoever state the name node was there in, it will be up to date to that location or to that state before starting the operations which the standby node has to do, or the name node has to do basically.
Okay.
Any other questions? Okay. So as I stated many times back also, the data nodes only contains the data, nothing else, and basically they periodically keep on sending the heartbeat signal, which I sent, which I told you right now. So and basically, so yeah, that's all they contain basically. The data, and they keep on sending the heartbeat signals to the name node, whether they are up and live, and the report of all existing blocks to the name node. So till now it's clear. There's something on name node, there's something on secondary name node, or in the two daughters architecture, there's something called passive node and data nodes. So now in this slide, I'm introducing two more terms, job tracker and task tracker. You can see job tracker is running on the name node and task tracker is running on the data nodes. So there are two more things which will start discussing from the next slides. There's something called task tracker which runs on the name node. Although it's not mandatory for it to run on the name node, but normally in a smaller cluster it's run on a name node. And there's something called the job tracker. It's not mandatory for the job tracker to run on the name node, but in a small clusters it normally runs on a name node. And there's always a task tracker which would be running on a data node. So what happens in the whole cluster? Let's talk about how the basically data is processed, or how the processes runs in the cluster, and how your data is really processed in the cluster. How everything is managed inside the cluster. That magic of data processing parallelly across the nodes, how that happens. So basically how your job is submitted to the cluster. Let's look at that part. So I as a user submit a job. The job tracker which I displayed over here, this guy, gets the job ID and compute the split. So for a time being, just assume split is nothing but a block, the block which we discussed previously in the slide where we place the data. So for a time being, just assume split is equivalent to block. However, there's a difference. There's a slight difference between a split and a block. that I'll explain you somewhat later point of time. But till that time, just assume split is equivalent to block. So we get the information of number of blocks associated to the file or associated to the data which you want to process, and the resources which are required for job to run are copied to distributed file system. That is the logic which need to be processed, which need to be applied on the data, is basically copied to the distributed file system, and the job is submitted. After the job is submitted, based on the split information, that is the number of blocks which are associated to the data which need to be processed. I'll repeat all this thing again because I know that you will not be able to understand a single flow. I'll repeat all of this again. So this job tracker puts your job in the queue, and the logic which need to be processed on the data is taken or read from the distributed file system which we have copied, and maps and reduce are created. So all of the data processing in Hadoop what happens in two phases. One is a map phase and one is a reduce phase. So maps and reduce are created, and the task tracker which runs on the data nodes, these task trackers which runs on the data node sends heartbeat signals to job tracker, same way the data nodes used to send. And by that way, job tracker knows which all task trackers are up and alive and what are the work they are doing. So job tracker picks jobs from the queues which it has placed into the queue and initializes those jobs or assign those jobs to the task trackers. In this picture, the task tracker is up and job tracker has gone down. Please be aware. So these heartbeat signals which are sent from the task tracker, based on that job tracker knows what is the task tracker is doing, how much bandwidth is available with the task tracker to do further tasks, the previous tasks which are assigned to the task tracker, whether they are done or not, these kind of things. So the tasks are assigned to the task tracker. Task tracker reads the data locally which is lying into this file system and creates a separate JVM to process that data. I'll repeat each and everything which I've spoken till now in detail, but till now, are you able to understand few little bit flow?
No, I'm not able to understand.
Nothing? Okay. Shekhar, are you able to get little flow? Don't know. Okay. So there's something called job tracker, which manages all your job across the cluster. So any of the job or any of the processing on the data which need to be done is managed by job tracker. Which data is lying where is managed by something called name node. So there are two things. One is a name node, one is job tracker. That makes sense?
Yeah,
There's something called task tracker, which is a process which runs on the data node, which really processes your data locally on the data node. So your data lies on the data node. So part of the data for each file lies on the data node. So that part of the data is processed by a process called task tracker. And task trackers are monitored or basically, uh, monitored as well as basically given tasks from the process called job tracker. So all the task trackers running on all the data nodes are monitored by job tracker, and all the data nodes are monitored by name node. There's always one task tracker running on a data node. There cannot be more than one task tracker running on the data node. And there's always one instance of task tracker running in the whole cluster In a smaller cluster, this runs on the name node. In bigger cluster, you might run it on some other separate machine, but always one instance of job tracker. And the machine which is running the job tracker has to be good enough or has to be of good configuration, because job tracker has the capability, or basically is a single whole soul person who is managing all the jobs which are running the cluster. So how the jobs are basically processed in the cluster? A job is submitted by the user. That job goes to a job tracker. Job tracker divides that job and assign a part of those jobs to a task tracker. So let's say there was a file of 5 blocks, and the first block of that is lying on this data node, second block of that is lying on this data node. So two processes would be one process would be going to this task tracker, one process would be given to this task tracker, and three other processes for the three other blocks of the file would be given to some other task trackers. And that's how processing happens in the cluster. And these task trackers keep on sending the heartbeat signals to the job tracker, so that job tracker knows the task which is given to these task trackers, how much that task is completed, what is the state of the task which is given to them. And these task trackers also keep on sending the signals, how much work is they have done, what is the current work they are doing, kind of thing, so that the job tracker knows if this node has a cap, let's say RAM of say 64 GB, and I have assigned him two tasks, and each task consumes 8 GB. So still, only 16 GB is consumed on this data node. Still, this another bandwidth which is available for this task tracker to do. So in that case, it will assign some other task to this task tracker. Does that make some sense to you now? I'll go further more deeper.
Yeah, little bit.
Shekhar?
Uh, so here like
Yeah, go ahead.
so like here we have two data nodes, like one and two. So what I understood is like job tracker, like all, each data node is having a single instance of task tracker, and those task trackers will be managed by job trackers, right? So like
Those
all the jobs will be
only one job tracker is there in the cluster, not more than one.
yeah. Job tracker is only one, but task tracker tracker can be many, but provided each data node will have single task tracker, right?
Yes.
Okay, and the example which you just gave, like it's having one is having maybe 8 GB available RAM, so it will divide equally, or it will first put all the load on one node and then only it will divide.
Mhm. Okay, okay. So the beauty of the cluster is, Shikar, are you there, or I don't know. So you remember we discussed this example. This file had 5 blocks, right? So these are data nodes. This file had five
Yeah,
blocks. So what will happen is there's a process called your job tracker which is running up, and your task tracker is running on all these data nodes, right? TT
right.
task tracker है ना? ठीक है?
Okay.
Now, let's say all of my data nodes have a configuration of, let's say, 16 GB for timing, yeah? 16 GB, 16 GB, and so on. Okay. And
Okay.
let's say right now this disk is doing and so basically, your each task which runs is given a particular container size, and each container of fixed sizes. They can be it's not mandatory, but normally there are fixed sizes. So let's assume one container size is of 4 GB. So each node can run 4 tasks at a time, right? If 4 GB is the container size. Let's say it's already running 4 containers, it's all red. Let's say this is running just one container and this has bandwidth still of 3. Let's say this is running 2 containers and it still have a bandwidth of 2. Let's say it's running 3 containers and a bandwidth of 1, and so on. Now I assign the task to my program to process this file of 5 blocks. I want to do some operation on this file. So now job tracker will see that the block 1 need to be processed, 2, 3, 4, 5 all need to be processed. Now it will see where all block 1 is lying. So it will coordinate with the name node, get to know the information about all the blocks which are associated to the file and where they are lying. Now it also knows that disk 1 is all full with other processes which are running up. So block 1, processing of block 1 cannot be given to disk 1. So now it has only an option of giving it to disk 6 and disk 7. So it, based on the availability and other things, it might give to 6 or 7. So let's say 7 is also free, so it can give for 6, give to 6 and 7, 6 or 7, anyone. Similarly, for block for 2, it can give it to this node because it has three available. It can give it to also if it has 1 available. If it is given for 1, it will not. It will be all red, so it will not be able to give to it, and so on for block 3 and so on. So this is how job tracker manages the resources across the whole cluster, how many resources are free on which data node and which blocks are associated to the file which need to be processed up, and based on that it keeps on assigning the task to the corresponding task checkers which are running on the data node. And it also takes care of lot many other things, like if let's say uh, I want to process this file and the block 2 lying in on this, and I've given this task tracker to process the block 2, but it failed in between. So the fail information will also be sent to job tracker. So next time when any processing request comes for this file, it will try not to give processing of block 2 to this node, and it will try to give it to some other node because last time it failed over there. So this node will be given least preference for processing block 2, and similarly for other things. So these kind of things are also taken care by the job tracker. Does it answer your question?
Yes.
Okay. Shikhar, are you back? Looks like it's slept back. Okay. So now I'll repeat everything again. So now you will be able to understand. I, as a user, submit the job. There's a process called job submitter. There's a small process which is running in the cluster, which basically gets a new job ID from the job tracker and computes the input split. Input split is nothing but, let's for a time being just assume these are number of blocks. So that file had 5 blocks. So it will compute there are 5 blocks associated to the file which I want to process. And uh, we copy the logic which we want to run on the data. Let's say we want to sort the data. So we'll copy this logic of sorting data for I is equals to 1 to 10 and kind of thing, sorting it. And that logic will be copied to distributed file system. And the job is submitted. Once the job is submitted, that job goes to the job queue. And the job tracker reads the information about the split, that is number of blocks associated to the file which you have calculated, and based on that we get mappers and reducers are created. So there will always be x number of mapper if there are x number of splits, that is always equal. So if file has 5 blocks, there will always be 5 mappers which are created. So there will always be one mapper for one split. And for a time being, assume split is block. Split is equivalent to block. So the number of splits which are calculated, the number of mappers created in the program will be exactly equivalent to that. So these task trackers, as I told you, keep on sending heartbeat signals to a job tracker. So job tracker picks a job from the job queue, which it has placed over here in this diagram. And once the jobs are basically initialize, one by one task is given to the task checkers which have capability or bandwidth to run the task, and these task checkers run the individual processes and send the status to the job tracker. And how this task are run, and at the individual task checker, for each task they create an JVM instance, and that task runs into that JVM instance, and to run that task they basically require the logic. So logic we have previously copied into DFS, SDFS, so that they read the logic from distributed file system and run that logic on the individual data which is lying on that data node. And once the data is processed, a signal is given to the job tracker that the data is processed. So does that make sense now? Now you are able to digest at least 50, 60, 70%.
Yeah, can you repeat this slide again?
Sure, sure, sure. So हमने क्या करा था? So हमने क्या करा था? There was data lying on each data node. So now this task checker need to process this data, and to process this data, what processing or what logic need to be applied? That logic is required by the task checker before that logic need to be applied. So that Java code, a small Java code which need to run, which is required by this task checker, what need to be run? So that logic is read from the distributed file system again. So this task tracker will read that logic from the distributed file system, that is SDFS. वो भी कहीं किसी नोड पे ब्लॉक से पड़ा होगा, वो वहां से रीड करके लाएगा उसे, उस लॉजिक को जावा जेवीएम में कन्वर्ट, बेसिकली जावा का इंस्टेंस बनाएगा, उसे रन करेगा, and on this block, and that's how the data is processed. So this is what I'm displaying over here. So there's an individual JVM instance which is created for each logic which this task tracker is running, or basically for each block, the processing which is happening on this task tracker. A new JVM instance is created, and that block is processed in that JVM instance, and that logic is read from the distributed file system. So this is what I'm displaying over here.
Miraj, I have a small question.
Yeah.
The Shaker.
Yeah.
So the JVM is spawned based on the new task which is coming to that particular task tracker.
Yes.
So, and how is the logic coming with it? Like, so suppose if the sorting, right? So where is that instruction coming to the data node?
This is the logic. That is a jar, the job jar. So when you submit the basically logic, that is a Java jar. That is a main class or main program kind of thing, and it just says Java and this file name. So that logic will run, and the data is the input to the logic. So a new JVM is created, and that is a logic with the data is an input to the logic, and that runs up.
Is this logic shared for all the data nodes?
Yeah, of course. That's a single logic, no? So that is a single jar which we copied over here. So see, we copy the jar to SDFS, distributed file system, and this is a jar which is read by this task checker. So this is a jar which is read by this task checker, and it runs a JVM instance for each task separately. So these task checkers itself is a JVM instance. The job tracker again itself is a JVM instance. All of these processes are itself by themselves is are JVM instance only. Data node as a process which is running again a JVM instance. All of them are JVM instances only.
All right, got it. Thanks.
Now my question to you is, why, if the task tracker itself is a JVM instance, why it should not just run the logic itself inside itself? Why it creates an overhead to initialize a new JVM instance for each process which it is running up, or each task which is running up?
Yeah, that was the same question I had. Why couldn't we have one JVM and why multiple JVMs are initiated? what I can guess is, I'm not sure, but what I could guess is basically there could be multiple logics which will run on the data node, and each would refer a different jar file. So, suppose files for one data set which is on, say, shown in orange, and there could be another file from another data set which needs a reverse logic. That's why they are creating different JVMs.
But that could be done in a single JVM, two threads or something. That could be.
That that's true too. Like, they have. I have no answer for that. I
So,
I was I was kind of having that question myself.
okay. So as I told you, so let's say I send logic of division by zero kind of thing or something, and the JVM crashed. So if the logic crashes, it crashes my task tracker also, and that made my data node down. So I don't want to reach to that situation. Something fails in the logic. It's just that JVM dies up. My task tracker is up and running always. Uh, at least I can maximize the probability of task tracker running up. So that's the reason a new JVM instance is created for each process or each task which is done by the task tracker.
Okay, say that again one more time.
So if something fails while processing the data, it's only that process dies down rather than all others. So if this task taker was while processing four tasks, and this task taker itself was running as a JVM, so if this guy was faulty, it will die. It will make all other four die also. But in such a scenario, only this guy will die. Rest all will be keep and up and running. Make sense?
Okay. Yep. So if I want to understand this correctly, and say suppose, for example, I'll just take an example to run with.
Mhm.
Okay. So in our previous example, we started with 5 block of file of data one, and you don't have to really go there, but we can just. So basically, you have 5 block of file. Help us a little bit.
Sorry, I missed you. So Shekhar, when you speak, there's some lag, but uh, when basically when Prabjeet was speaking, I was not able to hear any lags or any delays.
Okay, let me see if I can put a headphone and it works better. Is this better now?
Yeah, I think much better.
Okay, so I think it was because I was speaking too far from the computer. Anyways, so the question is, we started with 5 blocks of data in first file, right?
Hmm.
And let's assume that these 5 blocks are put into different data nodes.
Hmm.
So take first block 1, which was in data node 1 and 6 and 7, if I'm not wrong,
Okay.
right?
Okay.
Now, so suppose this data needs to be sorted in a ascending order. That is my task.
Hmm.
So what is going to happen is it is going to first go to the job tracker and it'll say that I need this data to be sorted in an ascending order. And a task tracker 1 would be initiated in 1 and 6 and 7, and separate JVM would be created, right? And data would be sorted out. Now, take the example of the JVM. So you have created JVM1 in 1, JVM2 in 6, and JVM3 in 7.
Okay. So I am what you are saying. I'm just trying to put it on Excel sheet only.
Sure, sure. So we have got JVM, 3 JVMs created for only okay. Rest 4 blocks are still to come. Now the
So
question
let's
which
say
I had was
these are the 3 blocks. Three is replicated thrice, two is replicated thrice, and one is replicated mm,
you have to do 5 and
thrice.
6.
Okay, let's say these are the 5 data nodes, and these are 3 blocks for the file, and all replicated thrice. Now you can say what you're saying.
Okay. So based on what we have learned so far, basically whenever this sorting task needs to go, what will happen is it will say that I want to create a JVM on 1. So basically on that data node, there will be 2 JVMs created, JVM 1 and JVM 2,
Yeah,
right?
it
For
can.
task,
Yeah, it can definitely do.
right?
Yeah, yeah, it can definitely do process 1, 2.
Yeah. So there are two, okay, so there are basically 2 JVMs created there.
So
But both JVM will refer to the same jar file.
yeah.
Okay. There is a possibility that there's another process running on it.
Hmm.
There's the same possibility that there's another process running, which is process P1 for another data set, which is still lives in that, right?
Yeah.
So you could see, yeah,
So
right?
yeah,
Now,
yeah,
okay. Now the question I have is,
yeah. Keep on speaking. I'm listening to you.
okay. So the question which I have is this, that this each JVM which we are creating has to refer a different set of instructions provided in terms of a jar file. Uh, and coincidentally, P1 and P2 is referring to the same jar file, but PX has to refer to a different jar file because that is a separate process altogether.
Hmm.
How will the fail of a JVM, which is PX, now ha help us better? In this example, can you just make me understand that whole thing?
Yeah.
Because it is
So
not very clear to me.
yeah, yeah. So this is the data node. These so this is let's say 4 GB each. So each container size is of 4 GB, and the let's say of the node is of 16 GB RAM. 16 GB plus some other thing. So normally it's 20 GB. So then 16 GB is given to your yarn for running these things, and task tag is taking 2 GB kind of thing and all those things. So what I'm saying is, let's say this P3X was a culprit and gone it gone out of memory. So if PX gone out of memory, it will not just be PX out of memory, it will be everything out of memory because everything is running same JVM.
Same
But in
machine
such
unit, not same.
same JVM, if everything is running on same JVM, what you are saying, if everything is running in same JVM, that is task checker JVM, which is given a memory of let's say 20 GB, that is all this thing. So if all this thing is given to a same JVM instance and everything is running in the same JVM instance, in that case, what will happen if this PX guy gone out of memory? This guy individually cannot go out of memory. Everything will go out of memory and everything will be down. But if I separate each and everything, but if I separate each and everything, this guy is running separately green, this guy is running separately green, and this guy goes out of memory, all others will not be affected, only this JVM will be killed. Sorry. Getting my point?
Yeah, yeah, I get it.
Okay, so let me rephrase what we discussed again over here in the Excel sheet we have already created, so that will make it more clear to you. So let's say each of these data node is of let's say so other than so I'm just talking about the memory which is assigned for the jobs to run up. So let's say each data node is of size 16 GB RAM, and name node should always be a good. So in such a scenario, if the data nodes are 16 GB, normally you will have a name node of 64 GB or 32 GB kind of thing. Okay, so your job tracker will be running over there and it will be consuming a lot of RAM. And in such a scenario, you can create containers 4 GB, 4 GB, 4 containers. And this is how your task will be given up. So if 1 and 2 are given to this guy, and third is given to this guy, so this guy is and let's say this guy was all red because something else was running up, so nothing came to this guy, and that's the reason third is given to here. And this guy also red, say. So that's how it's take care of all these things, and based on the availability of the RAM, where the RAM is available, all that is managed by the job tracker, because all the resources are managed by the job tracker, and that's how it comes to know where to assign which task. So now say another task comes up for another file which has a block number 5, and that block is lying at these 3 locations. So in that case, that could be given to data node 1 also and data node 2 also, because data node 5 is already all red. So that's how everything is taken care in the picture. And over here, let's say for this was 5 only. This was 5 only which gone out of memory on this node. So in such a scenario, it will try its best not to give reprocessing of 5 to this node because it has gone already down for this block 5 on data node 1. It will try to give it to some other data node. And such a scenario, it has no option other than giving it to data node 2 because data node 5 is already down, already full. So it will try to give P5 to this node now. Okay. So one thing I told you was I as a client, let me go back here. I as a client places my jar or the logic into SDFS, and that logic is read from the data node from that SDFS only. The replication factor of this logic in the distributed file system is not the default 3 1. It's higher than 3. It's normally by default 10. Can you guess the reason why it's 10 rather than the default 3? So all the data replication factor is 3 only, but the jar which is copied, the logic which is copied into distributed file system has a by default replication factor of 10 rather than 3. I think 10 or 7, most probably it's 10 only, but it's higher than 3. Can you guess the reason?
I'm thinking actually, I'm not sure.
Now one more, by the time you're thinking, let me tell you one more thing. Now you can see how I can achieve the high availability in the cluster and how I can achieve high processing in the cluster. Although the data was lying on this node, the block 5 is lying on this node, and this node is all red. I'm still able to process block file because I am available by block because my block file is available on some other data nodes which are free. So that's how I am able to manage the resources across the cluster by dividing by replicating the same data across the cluster. So that not only gave me high availability, that's also gave me high processing power in the cluster on the same block at a given point of time when some node is all booked, or the date node which is like which is having that block is all red. So because 5 is lying at 3 nodes, I can process at any of the node if 2 are still red. So that's the reason I'm also able to achieve high processing at a given point of time rather than other systems where we have write contingency, read contingency kind of thing in the Oracle kind of systems or other file systems. These kind of things are not visualized over here because we have the data replicated 3 nodes, and that can be processed and read or written anywhere. Otherwise, if we were using Oracle kind of thing, all the write request, read request came to this node. This node was all read, and uh, we face issues with particular tables. Those are not written, read properly, kind of thing. So these things do not happen over here because the data is replicated across the cluster and with the replicant high replicant factors.
So the output write is not restricted to where the input file is read, and that's why the jar replication factor is higher than the data replication factor.
Output write is not. Mm, so basically, output return, how the output is written and how the input is read is little complex. We'll come to that part in MapReduce part. But the answer which you are saying is not what is the reason behind this thing.
Okay.
So basically, the thing is, so this jar or the data need to be read by only one process at a time, which is processing the data or basically the block. However, this jar need to be read by n number of task trackers which are running on n number of nodes, because the file, when I'm talking about file, I'm really talking about petabytes of file or terabytes of file, and that file might be divided across 100 nodes or 500 nodes or 1000 nodes. And on all of those 1000 nodes, there will be hundreds or thousands or hundred thousands of individual blocks for that file, which will be reading the jar and creating the instance of the JVM. So that's practically need to be read n number of times. To make that highly available or nearby available to the data nodes, that jar is copied with a replicate factor of 10, so that if let's say these three data nodes are on rack 1 and these are on rack 2, and so basically whenever any read request is given, so data node 1 want to read anything or client sitting or data node 1 want to read anything, name node will return the nearest location of that of that data. So that's the reason your the replication factor of 10 is given to this jar, so that your data or the logic, because it need to be read by pretty huge number of nodes. So the reads become fast for that logic, and basically that is highly available to all the nodes. And as that logic is of very small sizes normally, so that does not is a high or basically costly for to copy that with high replication factor. Make sense? Yes, no?
I'm not sure. I was waiting for Vijit, but I didn't get the clear picture of why, if it is not only three, then it will not work that way.
It will work definitely, but it's just to make it more available, more widely available to the nodes, because this will be read by n number of nodes at a time. It's
Okay.
just to make it more highly available. It would, even if it would be one, then also it would have been read. But to make it more highly available, so let's say I have 15 racks in the cluster. Let's say I have 15 racks in the cluster.
So there is no formula saying that if it is three, suppose if your data is replicated three times default, then the jar replication factor is should be at least three or higher.
No, it's by default is 10 only. Again, it's configurable by default is 10.
Yeah, I'm good with that.
So getting my point. Can't get much. So let's say this is your rack 1, rack 2, rack 3, rack 4, and similarly, and so on. So if that had, let's say, replication factor of 3, so one copy of that logic might be lying on rack 1, and one copy might be lying on rack 3. So there would be inter-rack communication between rack 3 and rack 2 when that process need to be run on rack 2. So basically, to make that highly available or nearby available, there's a high replication factor which is made for the logic. If it's 10, there's a high probability that is available on rack 2 also, rack 4 also. So that will be as nearly available as the process where it's running up. It need to be ran up. So does this whole flow make sense to you now, or shall I repeat it again?
Uh, if in case one task is dependent on some other task, like output of some other task, so is it possible first?
So
And second,
yeah, MapReduce chaining is possible, but that only happens when your first MapReduce phase is done. Then only second MapReduce will run up.
okay, but here we are talking about the independent task, right?
So independent tasks are nothing but your so task is nothing but is a process which is processing your one block of data at a time. So if these are 4 blocks lying on this data node, one process is running only on one block of the data. So that is a task.
Okay.
Any further questions on this flow? Shall I repeat it again? Or anyone else want to repeat it again?
Yeah, I think I can try. So basically, job tracker gets the heartbeat. Do you want me to try it,
Yeah, please go ahead.
Miraj?
So I'm on the first slide. Please go ahead.
Okay. Okay. So user submits the job to the name node, which is running the job tracker. So job is submitted. Job tracker gets you the job ID. Once the job ID is got, then basically it finds out how many compute steps are needed. Basically, how many data node this file is split into, and then a central repository of the logic is submitted, copied in the DFS file. So once that is once that jar file is copied in the DFS file, what is going to happen is then it is going to initiate, go to the next one. So once the jar is cop copied in the DFS, then it will start running the individual task trackers in the uh, uh, basically each data node.
If task takers are always running up, it will keep on assigning so basically now that single task need to be basically ran 5 times or 15 times based on the blocks. So each task taker is then given a task to run that basically job individually on the blocks. So task taker is assigned the task to run that thing on the individual data blocks.
Yes.
And these task trackers keep on sending the heartbeat signals to the job tracker. By the virtue of that, job tracker knows what is the state of the task assigned to these task trackers. Also, if the task tracker is not given any heartbeat signal to the job tracker at a predefined frequency, it's assumed that the task tracker is down, and then in such a scenario, it assigns the task whichever is assigned to that task tracker to someone else which had that data copy of the data. So that's how the process is maintained by the job tracker, even if the task trackers goes down or data nodes goes down.
Is this not a So suppose if is this a better design if we do only one JVM because each JVM, I'm just thinking, it's like, basically if it is a 4 GB machine, then each JVM will get only 1 GB to process it, right? Even if 3 GBs are not used,
No, so
right?
basically, the thing is, the containers are configured in such a way that there is a minimum allocation to a container, and there is a maximum allocation to the container. So maximum can be 1 be 64 GB whole RAM size, and minimum can be 1 GB, 2 GB kind of thing. So based on the requirement, the containers are extended by a yarn, which manages the cluster in your two routers architecture. So that's all thing is configurable and achievable what you're thinking of.
Okay. Yeah, I think we will have to learn more of how the processing happens so that to get a clear picture of.
Yeah, definitely slowly and slowly you will be able to digest all
Okay.
these things. Hmm. Okay. Any further questions? Okay. Okay. Shall we take a break of 5 to 10 minutes?
Yeah, I'm good with that.
So it's what's the time? So it's 21:54 in my watch. Let's meet at 22.
Yep.
Uh, sure. After 6 minutes. Okay.
Yep.
Hey, back.
Yeah, I'm back.
Okay. Pravjit back.
Yes. I'm there.
Okay. Okay. So, so I also shared few minutes back only those links for the shared drive also. So you can just download the things and we'll keep on discussing those things and slowly I'll tell you how to install everything also. Don't worry about the installation part of the software. What to use where I'll explain you all those things. You can just download all those things so that the download you don't waste the downloading time when we are discussing that thing. So you can just put in your laptops. Okay. So basically, as we discussed, job tracker. So that's all we've discussed. I hope you would have read it again. And this is what we discussed about task tracker. Manage the execution of individual tasks. One task each data node. One task tracker each data node. Store separate GVM. All those things which I discussed. Heartbeats. I already discussed. Data nodes keep on sending heartbeat signals to the name node. So this is how the writes happen in the cluster, although I discussed it with you previously, but let me quickly walk you through how the write happens in the cluster. So basically, I as a client give the write request to the name node. Name node do not do any write. Name node is just a coordinator in our cluster. It contains the metadata. So it will just tell me as a client where to write the block. It will return me the name of data nodes, where to write it. I, as a client, it's my responsibility to write it to the corresponding data node. So I will send a write signal to the data node 1. Data node 1 will send a write signal to the second data node, and second data node will send a write signal to the third data node. That's how the data flows in the cluster, and that's the reason the second and third copies are placed on the other racks, because of this transfer. Inter rack is costly for, and the 3 sends an acknowledgement to 2, 2 sends acknowledgement to 1, 1 sends acknowledgement to client, and client sends a complete or acknowledgement to name node. And that's how the whole write happens in the cluster. Now let's say while writing this there's a failure, or while writing this there's a failure. What do you think will happen?
Does the data node try another data node?
So this is 1, this is 2, and this is 3.
So if two write node fails, then will one try another data node?
It will not try another data node because this client will give a write instruction to data node 1 that write it to yourself and copy it to 2 and then copy it to 2 will copy it to 3. And because name node has
So
given this
if
instruction.
right, so if two fails, then it will just send that one acknowledgement is successful and send it to client. Client will go to the name node again, and name node will assign a new data node.
Yeah, so yeah,
Should.
almost similar thing happens. Let's say this fails, or let's say first this thing fails. So if this thing fails, 2 will send an example to 1 and 1 will send it to this thing and name node will get to know it's copied on 1 and 2 and write is made successful. If let's say, एक minute, let me clear this discard. So
So in that case, Nuaj,
I
will
know
it?
your question. I'll just answer your question. I know your question.
Sure.
Just give me a minute. Uh, so and let's say if this fails, so now you're 1, 2, and 3. So one node that it need to be copied to 2 and 2 will copy to 3. So in such a scenario, it will send the right signal to 3. 3 will send an acknowledgement to 1. 1 will send an acknowledgement to SDFS and sends it complete to name node and 1 comma 3. So your question was what will happen, the where will the third copy goes? That was the question, right?
Hmm.
So basically at the back now name node knows that it's partially copied or basically it's partially replicated. So at the backend name node will send a write signal to some other data node that will be transparent to the client and at the backend name node maintains the replication in the cluster. So name node will send a write signal to either 1 or 3 to copy it to some other x data node and they will copy it to some other data node. So that name node will coordinate at the backend.
Okay, one more small question. So initially I thought that only data node 1 has it to 2, but if it 2 itself fails, that chain is broken. But how does it know to go to 3 as the next node?
Because
It
it
all
because
this.
name node returns 1 comma 2 comma 3 to client. Client sends a
Okay,
write
okay.
write request to 1 and 2 comma 3 to zit.
Okay, okay, got it.
So this is how your writes happen. So this is what I talked about. And this is how the read, whenever anything need to be read, we coordinate with name node. Name node tells where the block is lying up. And it also ensures it will return the nearest location of the block to the client so that there is no delay in the reads and client then reads it from the corresponding data. There are processes which are running at the back end for the data correctness and data is also checked for its correctness before it's been read. So checksums are basically created on the data. The algorithm which is used by default is CRC32. And so basically at the back end there are also checksums keep on running up. So if let's say data which was copied where the block which meant to be there on 1, 2, and 3 was find out corrupted on data node 2. So name node gets this information and at the backend again informs data node 1 or 3 to copy it to some other X data node and from 2 the bread block is deleted. So that kind of process runs at the backend to ensure the data is correct and proper in the cluster. Okay, so that's all for the basic part. Any questions?
So
Anything
what is the
which
value of checksum? Yeah, what is the value of checksum?
value in terms of?
Uh, what does checksum validates? So basically, you
Okay, so checksum is something like let's say this is my data So there's some hash function applied on the data that returns, let's say 34. So this is how your data is kept. So this whole thing becomes your data. And when the data is read, this hash logic is applied to the data, and if there's something missed on the data part, this 34 will become something else. So practically that will be 1 zeros only, 1 and zeros only. So these 1 0 will become something else. So that means that there's something missing in the data. So the data has got corrupted, and that need to be replicated to some other data node, and this need to be marked red.
Okay.
Okay. Any other questions which we skipped last day, or anything anything which you want to ask before we move on to something else? So oh shit, I'll share this PPT on the Google Drive as soon as I'll be completing the PPTs. I'll share them on the Google Drive. Let me bring my charger. Just a minute. Okay. So let me show you how everything looks like, and let me show you the beautiful black screen of Hadoop, and that will give you a little idea. And then we'll look, and then we'll move on to some other things. So uh, I'll just pause the screen for a minute. So what I've shared with you is a pre-configured, totally packaged Hadoop flavor from Hortonworks. So that contains all the components which are required to make the whole cluster. So all the processes which are required for the cluster are basically configured over there. How to make this Oracle VirtualBox up and running, and how to install that image onto Oracle VirtualBox. I'll explain you each and everything. But let me first show you how it works, how it looks like, and what we're talking about, how the reads and write happens, all those. Oops, what happened? Where's my image gone? What happened, man? Just a minute. I think is some Windows DLL which is updated. Ah, okay, I'll show you it from on my other laptop. Not a problem. So I'll show you to another laptop. Give me 5-10 minutes. But what I've shared with you is, so can you see my screen now?
I can see it.
Okay, you can see my Google Drive, right?
Yes.
Okay, so there's a folder called Hadoop software which I shared with you. That contains Eclipse, which we'll be using for looking at the MapReduce code and other things. So probably you both are Java guys, so you would be having that. If you don't have, you can just download this Eclipse. And also you can will be using Maven for compiling all the code. So this document talks about how to install Maven plugin into Eclipse, and if you have already Maven plugin, that's fair enough with you. Then here's a JDK. If you don't have the JDK, you might be requiring up. Here's a Maven which you can download on your PC and install. So installation steps are here. You can just follow them, and there's nothing great in Maven. You have to just download a zip, unzip it, and set two parameters: Maven home and JVM home. So and that will install Maven on your PC. This thing you don't. Okay, so can you can just try running this thing on your laptop, and that will tell you whether your laptop is compatible with the virtualization. If your laptop is not compatible with virtualization, that is only case if your laptop is aged old, that is 5-10 years old. Otherwise, it will be definitely be basically virtualization enabled. If that is not virtualization enabled, then you will not be able to run the VirtualBox on your laptop. So this is only required if your laptop is very old. Uh, so here are the VirtualBox images, which will be so there are two things over here. One is Oracle VirtualBox, that is an installable. If you once you install Oracle VirtualBox, mm, virtual VirtualBox. So once you install this exe, it will open a screen something like this. But these things on the left hand side which are visible to you will not be visible. It will be a blank. So after that, you will download these OVA files. If your laptop has 4 GB or less than that RAM, use this 2.1 is fair enough with you. It has all the features, all the things which we require for the training, as well as for you to try a number of things. If your laptop is greater than 4 GB, you can try 2.2 or 2.3, and even 2.4 is now available. I'll share the link for 2.4 also. So how to
So,
install? Yeah, go ahead.
between those two, is there a big difference between for 2.4 and 2.1?
Um, all the basic things, all the major things are there in 2.1. To 2.4 have lot of other things like they have configured Spark also in that. They have added Knox, they have added a number of new things, but those are all advanced things which we might not be talking in the training also, and you might not be looking at those things until you understand all the basic concepts and you really burns your hand on those things. So for you 2.1 is much more than sufficient. Indeed, for you to work in a production environment in your office, 2.1 is much more than sufficient if you are not
Yes.
looking for real-time processing kind of thing. Um, okay, so what I was saying. Okay, so once you install this exe, it will open a screen something like this, and you can download this OVA file. And how to install this sandbox? Again, all the instructions are given over here, but let me tell you. So, and if you get some errors, there's a step in this document only at the end which talks about if there's an error, what need to be done with that error. So that talks about the error, and you can open it later on. So basically, that will talk about if this is the error, what need to be done. If that is the error, what need to be done. So what you have to do is just go to File, Import, and browse that OVA file and click on Next, Next, Next. And after some time, you will be able to see your sandbox over here. Right click and start it. It will start up. It will start lot of things. When you will see, it will start lot of things. And once it's started, you can open Putty. So Putty is also shared with you. You can just download Putty. Give IP address. You can write it down if you want. 127.0.0.1, and ensure you have mentioned port as 4 times 2. 2222. Sorry, I don't download it. Port as 4 times 2. User as what is the user? User as Hugh, H-U-E Hugh, and password as Hadoop. I'll ping. IP as 127.0.0.1. Port as 4 times 2. User as Hugh. Password as Hadoop. So once you log in, it will ask you for the user and password on the putty screen. User is you, password is Hadoop, all in small. Right now, I am not able to start this guy, so I'll show you another instance of Hadoop. For that, I have to log into other laptop. Just give me a minute, I'll log in. And that's that. This is a virtual box which we're using for our all our programs, for all our practicals thing. And you can install all of this thing on your laptop. I need to start my own, but I don't want to waste my time in debugging the error which I'm getting right now. So I'll do it later on, and right now I'll show you another instance. So just give me a minute. I'll log in.
What, what is the IP
I pinged
127.0.0.1?
on yeah, I pinged on the chat window. So this is the IP. This is the port which you have to give. SSH, and you can just open it, and it will ask you for the user ID and password, and just type U in Hadoop. So
So tell me one thing,
yeah,
are we setting up our own server or it is just connecting to
no, you're setting
else?
your own on single node cluster. So there's only one node running on that, and all your name node, task tracker, job tracker, data node, everything running on the same node. So this is a mini single node instance which you are creating for all the processes which are required to run your Hadoop cluster, all configured in this OVA file, pre-installed, pre-configured in this OVA file. So everything is running on a
So
laptop.
which is the,
Yeah, go ahead.
so go to the hard drive,
Hard drive means this Google Drive.
Google Drive, sorry.
Yeah.
So we Maven I already have. Uh, I have everything. So uh, which under the virtual machine folder, which file I have to?
You have to download this thing, or you can download VirtualBox, Oracle VirtualBox from the internet also, the latest version. This might be a little older. And you can download this OVA. How much RAM you have?
So there's a VirtualBox 4.312.exe. That is what I have to run 104 MB file.
100 yeah, .exe file. and how much RAM you have. Based on that OVA, you can download the OVA file. I'll share the link of the latest one also. If you have 16 GB, you can download the latest one also. If you have 16 GB RAM, but don't download the 2.4 without 16 GB RAM. If you have less than 16 GB RAM, I'll request you to either use 2.2 or 2.3 version. 2.3 might be lying somewhere in my laptop. If you want me to share, I can share it. But again, there's nothing great you will be paying with 2.3. You can use 2.1 or 2.2 also. So basically, you have to download this thing. You can download the whole software folder. You can just zip it and download everything because that contains the installation document and everything. You might be later on using it. And Maven Eclipse, you definitely would be having it.
Can I use IntelliJ?
Sorry,
Can I use IntelliJ instead of Eclipse?
can you?
IntelliJ idea.
Yeah, you can use anything, but if you're using IntelliJ, the project which I've shared with you, that is the code folder which I've shared with you, that contains your
Okay.
Eclipse INI file. So you have to convert it to IntelliJ and import it as a project. So that is access step which you have to do yourself. Otherwise, you can use anything. So it's all up to you, IntelliJ or anything.
Okay.
So what I'll do is I'll show you one cluster. So just give me a sec. I'll be logging in from another laptop because there's some problem with this one. So what I'll show you right now is a whole cluster which contains many nodes and how that looks like and how basically we run Hadoop commands on that. So
So Miraj, can I ask you a question?
yeah, by the time you can ask me the question, by the time I'm opening up the next other laptop.
Sure. So I just wanted to understand this whole environment setup which you are trying to do.
Hmm.
So to set this up in our own computer, uh, can you just run us stepwise
Yeah.
what
So basically, first you just go to the VMs folder. There's an exe file over there. Download it and just double click it and run it. It will open a box something like this. However, the left hand side, these lot of things, what you can see, hot and works, that thing will not be visible to you. Other than this, everything will be visible to you. So you will see a blank screen, like a blank screen, but that will contain that will have new and settings kind of thing. Okay, so you will be able to see Oracle VirtualBox Manager without anything inside it. So that's the first step which you have to do.
okay?
After that, you download the OVA file, any one of that 2.1 or 2.2, any of the OVA file. Wheresoever you have downloaded the OVA file in your laptop, just click on File on the Oracle VirtualBox, click on Import Appliance, and click on this browse button and select that OVA file and click on next. And once you click on next and finish, that OVA file will be visible over there as something like this, Hortonworks Sandbox 2.1. And you have to click on this start button and it will start some process, black screen to you. And that will take 10-15 minutes for a whole process to start up, and it will at the end it will say started. So I'm not able to show you that it started right now. I'll show you that it started in your next class. Right now I'm showing you the live cluster. Or let me see if my another laptop, if it would be running up, so I can show you in the other laptop. Uh, yeah, it's running. So I have a 2.3 instance over here. I'll show you that thing. Okay, just let me log in from the other laptop. Let me copy the meeting ID. Give me a minute. So, mhm. So by the time you can just try installing the Oracle VirtualBox Manager. Downloading the OVA file will take time to you. You can do that later on, but by that time you can just try download installing this Oracle VirtualBox Manager. And
Does it have a different version for Mac or PC?
हाँ मैक के लिए यार you can download the Mac so you can just Google Oracle VirtualBox and you can download for Mac.
Okay.
So I'm also download, or if you want for Mac, I can share it to you. I'm right now on Mac only, but you can download it directly from the internet. Just Google Oracle
Yeah.
VirtualBox Manager.
Okay. No worries. What I'll try to do is I have a PC at my for my work, so I'll try to set it up because most of the things are set up in my machine. Uh,
Yeah, you can whatsoever laptop or PC or whatsoever you want to use uh, uh, for the practicals, you can download it over there.
1 hour. Don't disturb me, please. Close the door.
So both of you are using Mac or Windows?
I can use Windows. I'm not sure. I don't have to use Mac, but
I
if I
generally use
understand,
Ubuntu.
Sorry.
Sorry, go ahead.
no. If I don't have to use Mac because my work computer is Windows and I can try to set it up, but I'd like to set it up in my personal computer, which is Mac. So once I understand the concept, then I can do it in Mac also.
Yeah, so it's all same, nothing great. Uh, just give me a minute. I'll show you from the other laptop. So I'll just make myself as a presenter. Just a minute. Change presenter to Mirage. So now you can see the screen on my Mac.
Okay.
Yes.
Yes.
Okay. So this is another Oracle VirtualBox Manager. So here, what I did is file, import appliance, and that OVA file which I was showing you over there, and just click on import and click on continue. And once you do that, this will be visible over here, and then you have to just click on start. So that will start
So
something
Miraj,
like
is this a different OBI file for Mac? You
no
said?
no 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 OVA file is same. It's just the rather than exe you have to use this Oracle VirtualBox installer for Mac. And
Okay.
it will start something like this. So it will start all the components, different components which are required for the whole cluster. So there are a lot of things which are at the backend which are required for most of those things to run up. um, so it will start a lot of things like this.
Actually, my work PC is having Ubuntu. So
You can use Ubuntu also, but for Ubuntu
what should I?
Ubuntu 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 uh, Ubuntu Hmm. I am not sure how you will enable virtualization in Ubuntu. Hmm. I have to check for Ubuntu, yeah. I am not sure about Ubuntu. For that, basically, you have to do manually install the cluster. That I
Yeah.
know, but use this ready-made solution which I am sharing right now on Ubuntu. I am not sure. Mhm. Actually, how to install the whole cluster, that part is covered as a part of admin of Hadoop. But if you want to do it really on Ubuntu, I'll share a document which talks you how to create a Hadoop cluster, and but that will only install the basics of that basically the Apache vanilla flavor of Hadoop. That will not install Hive and Pig and all those things. That all of those things you have to do manually for on your cluster. I'll share a document how to install the basics of basically the real basic only single component as on your Ubuntu machine. I'll share a document for you. But you can just try out if the Oracle virtualization kind of thing or VMware kind of thing is available for Ubuntu. If that is available, I'll help you how to do it on Ubuntu also. So I'm not sure if Oracle Virtual Machine or VMware kind of thing is available for Ubuntu. If that is available, I'll help you how to do that on Ubuntu.
Okay, thanks.
So
Meanwhile,
once,
I can try on.
yep. Uh, I'll also just Google it out. So once it's all started, this something like this will be visible to you, a screen like this. So over here we can directly go to the terminal rather than putty, and so on the terminal you can just say SSH and u at the rate 127.0.0.1. So rather than putty, I am using the terminal in Mac, and
I think you need to specify
yeah,
the
it's made
port
a
as
port. Yeah.
well.
Yes, yes, yes. So I'm just just opening that shortcut only. Just a minute. Uh, SSH. Oops. So basically minus P, I have to give minus P and port number. So I just created a shortcut for that rather than that. So I've logged into the cluster now. So you have to give SSHU at the rate this minus P करके port on your Mac. And that is 4 times 2. So now I've logged into the Hadoop cluster.
Same port at 222,
4 times 2.
2222, right?
Yeah, 4 times 2. So now you can say Hadoop fs minus ls and root. So this is my Hadoop file system which I'm right now looking at. ls. So for all the Hadoop commands to run up, you have to prefix them with Hadoop fs. So those are Hadoop file system commands, and after that it's similar to your Unix thing. So ls is this directory kind of thing. So I gave Hadoop fs minus ls, so that listed the directories in my at the root of my Hadoop SDFS cluster. So these are directories lying at the root on my SDFS cluster. So you have to just prefix that thing with Hadoop FS. So there are a lot of things which we can do with the Hadoop FS, Hadoop file system command. Uh, so to see the list of all those things which I can do is Hadoop FS and just press enter. That will show you all the lists which you can do with Hadoop file system command. So these are a lot of things which you can do. But the most usefuls are copy, get, put, make directory, remove. So let's try a few of them. Hadoop fs minus ls. So can you tell me right now what happened when I press this command Hadoop fs minus ls? Can you explain me what happened internally?
I think it will go to the root, it will list all the root directories.
That's okay, that is listed, but what happened at the back end?
Again.
अंदर क्या हुआ? My client interacted with name node returned the metadata is displayed over here. Now I say Hadoop fs minus ls slash tmp. So let's go to slash hive. कोई फाइल नहीं है क्या यार? Slash u. Yeah, there's some file. Loop fs minus tail with a directory. Oops, man. Oops. I'm just trying to figure out some file. Is the zero size? No. So tail is similar command to what you do in Unix. Man, just a minute. There's no file. Okay, what we'll do is Hadoop fs. Okay, before that, okay, ls. What's lying over here? So there's one file. So Hadoop. So when I did ls over here, these are files on my local Unix system on which Hadoop processes are running up. So when I did single ls, these are the files which are visible on the local Unix system on which Hadoop instances are running up. I'm again repeating the same thing. If I said Hadoop fs minus ls, these are the file system which is visible in the Hadoop file system. So there are two file systems which we are talking right now. Now what I do is Hadoop fs minus put. Put is putting something from local file system to Hadoop file system. So let's put this license dot file to slash temp in Hadoop HDFS file system. So what I did is Hadoop fs minus put license.txt into temp and HDFS file system. So now can you tell me what happened in the backend?
Hey, Milal, Shekhar, I think I lost my connection for last 2-3 minutes and then came back. So
Okay, so what I was trying to do is I was just trying to run few of the Hadoop fs commands. So we just ran Hadoop fs minus ls command, and then we just put one file from the local file system. So there are two file systems. One is the important thing which I discussed about it. When I just type this ls, that shows me the local file system that is on my Unix system file system. On so this Hadoop as a process is installed on Unix file system or Ubuntu or similar kind of file system. So when I typed ls, this is my local file system. When I said Hadoop fs minus ls, that is the file system which I'm looking at Hadoop file system. So there are two file systems you're talking over here. One is the Hadoop file system, one is the local file system. And after that, what we did is Hadoop fs minus put. So put is putting something into Hadoop file system. So this is a local file which is visible with this ls command. So I tried to put this local file into /temp folder of Hadoop, and this file is placed now. And now what I'm doing is Hadoop fs minus ls/temp. So when I do this, that license or text will be visible over here. So license or text is here. So this is what we discussed till now, Shekhar. Any confusion right now?
Miraj, this is Shekhar. Saying maybe 4 minutes. So can you go up on that screen? I wanted to review last few commands which you put.
Yeah, so these are the only
And
three commands which you put. One is Hadoop fs minus ls. One is ls, that is a local file system. Hadoop fs minus ls is a file system of Hadoop. And then we put a file from local file system, that is license.txt, to the /temp folder in Hadoop. So these are the four commands which we ran.
okay. So you were I was hearing like a little bit break in what you're speaking, and then I lost the connection altogether. So can you review last 5 minutes quickly with me?
So these are not, yeah, that is what I'm saying. This is what I discussed in the last 5 minutes. So you were able to see when I logged in to the cluster, right?
Yes.
Yes. So after that, all these are only five things which I discussed.
So when you say to the cluster, then that is, as we discussed, this is a single node cluster, which has got both data node and
So all the
correct?
processes, yeah, all the processes are running over here. Data node, the name node. Hmm, well, it's not displaying. So all the processes basically
Yes, man. Yes.
so all the processes are running over here. Data node, name node, and all those processes are running over here. All those things are configured for you, and all these things are running over here in the cluster. And yarn node manager, all those things are running. So everything is busy, so you don't have to worry about anything. You have to just click on the start of this thing, and it will start all the required things which are required for you to run the whole cluster and different components inside the cluster. So there are a lot of other things which run in the cluster which makes our life easier. We'll slowly and gradually discover them. So this is everything configured in it.
Okay.
Okay, so to look at all the Hadoop FS things which are available to you is you can just type Hadoop and FS and press enter. So that give you the list of the commands which you can run with Hadoop FS. So put we just now tried. Similarly, there's a get Hadoop get. So now if I want from temp the license file which I copy in the text over here in my local directory, so I'll just say license.txt and I want it over here. So it will get it from there. Sorry, Hadoop fs minus cat. So it will get it over here. But right now file is lying over here, so shit, error मार देगा. So this is how I can get the file already. So then MV to move any file inside the Hadoop file system, move to local is similar to get. And similarly, CP is copying from one destination to another inside the Hadoop file system. Changing the permissions of the file, get the file, tail. Okay, so I was running the tail. So that time I was not able to find out any file to tail. Now I find out a file to tail. फाइल नहीं है क्या मजाक कर रहा है भाई hadoop fs minus tail slash temp license hadoop fs minus ls slash tmp hadoop fs minus tail So now can you explain me what happened when I typed this command? So this copied some last bytes of the file over here. क्या हुआ बैकएंड में? प्रभजीत?
I'm just trying to relate with what, like all the components which you explained earlier about the name node and job tracker, task tracker. So
So task
I
tracker
think
and
this
job
is
tracker, task tracker and job tracker does not come in picture till now because we have not ran any process. We have just reading the data or putting the data. So in that case, task tracker and job tracker will not come in picture. Task tracker and job tracker will only come in picture when we'll run some process, really process the data. So right now we are not processing the data. We are just interacting with the Hadoop file system. So here what I did is I just said a tail. So I interacted with the name node. Name node gave me the locations of log of this file. I interacted with the data node, read the data and displayed it over there. Although it is a single node, so everything happened on the same node, but in a cluster that happened on a different nodes.
explain a little bit more about this file, like physical. This is one file, right? So will this file is also distributed between different data nodes?
File तो यार blocks में divided होती है ना. There's nothing like file. Everything is divided into blocks only.
Right.
And blocks lie
So
on the
ये
data
सब
node.
वो
And there are the
okay,
individual
okay.
blocks which lie on the data nodes. So this is how your whole cluster is looks like. There are a lot of nodes which will be associated to the whole cluster. So right now the cluster which I'm showing to you has 21 nodes. Each node with some node with 120 GB RAM, some node with 60 GB RAM, and the processor runs on these nodes. And there's one name node, one or two name nodes. So these are two name nodes of this cluster. Uh,
Miraj, which is this cluster?
this
Where did you
this
connect?
this is my own cluster. So I just connected on another laptop. So this is my own cluster. I'm just showing you live cluster which we use for different purpose. So there are a lot of processes which runs on the cluster. I'll show you all these things later on. But right now I'm on the live cluster, so I thought to show you the live cluster rather than showing you a single node cluster. So there are different processes which runs on the cluster. Uh, then all the jobs which runs on the cluster. So So there are a lot of things which run the cluster: SDFS processes, yarn, MapReduce. Stage will talk about. Stage will not talk about, but I'll explain you a little bit. Hive, Woozy, Ganglion, Angios, Copier, Peg, Scoop, and everything is going to be configured from this UI. So this is Ambari UI. I'll talk about all these things. I'll explain you this Ambari UI a little bit. Although this is the admin part, but I'll explain you this Ambari UI a little bit. So this is how the whole cluster looks like. There are a lot of nodes which are interconnected in the cluster. So we can log into any of the node. Let's say log into this node. So SSH. So I'm connected to one of the node in the cluster, and whatsoever I can do any other node, I can do on this node also. So Hadoop fs minus ls, and same result will be visible on any other node. So I as a client can sit on any of the data node and run my processes, run my commands, like I can do anywhere. Here on from here only I can trigger the jobs, jars, everything. So I can just log into any node I can and do the processing. So, but we'll be using the single node cluster because you want. So this is a cluster right now installed on AWS. Otherwise, you have to buy some space on the rack space or somewhere and run it everything. So it's better you can just use your own laptop and this pre-configured setup to do the things. But if you really want to do that, run the admin part, then I'm not the best guy to help you up. But I can help you up how to set some basics. You can even create your own cluster. So that again you can do on your laptop if you have good enough RAM like 64 GB or 100 plus GB kind of RAM on your laptop. You can run your own cluster on the laptop also. You can create a small cluster of 1 or 2 nodes, or 2 3 nodes kind of thing.
So these all are AWS cluster or some cluster are running in your local machine also.
No, this right now I am showing you is the AWS one, but that what I showed you previously was a single node thing. This was a single node which is running on my PC. This is the cluster which is
Yeah.
running on AWS.
Okay.
Okay. So I wanted to start new topic, but we are almost already done with the time. So let's start the new topic later on only. Otherwise, it's just 5:10. And although we are almost done with the time. So while I start with the basic MapReduce, and before that, I'll talk about some of the Java code, which how to interact with the Hadoop file system from the Java code that might be useful to you. So we'll just talk about for 5 10 minutes about a small Java code, how to interact with the Hadoop file system. Then we'll look into the real MapReduce algorithm, how the MapReduce algorithm works. Okay.
So is the next class on 8 o'clock
Uh,
Saturday,
e-
8:30?
yeah, next class we can have on same time on Saturday and Friday is also holidays. If you want to have a class on Friday, we can have a class on Friday also.
Actually, yeah, last time I told you like I'm traveling tomorrow morning to Pune. So
Acha.
I'll be back on like Saturday night, oh sorry, Sunday night. So
Sunday
is it
night.
possible if we can have like maybe Monday, Tuesday sometime or Wednesday, if it's
Uh,
fine with the
Actually, then
you?
we'll miss 2 classes, yeah. If you can manage at least one class, because otherwise there will be a lot of delay. You can take a call from Pune. The beauty about this whole system is you can take a call from anywhere in the world.
Saturday evening I can try, but Sunday same time I'm having flight.
Yeah, so if you can try on Saturday at least.
Okay, I can try.
Okay, or on Friday also I'm fine with it because Friday is also holiday.
So we meet on Saturday.
Yeah, let's meet on Saturday, same time, and then on Saturday we can discuss if we want to skip Sunday. But let's meet on Saturday at least.
Sunday class we will do it on Wednesday or whenever,
Yeah, yeah,
right?
yeah, sure. That we can discuss on Saturday only.
Most tentatively
Okay.
Saturday we are meeting, and then we'll decide on the Sunday class on 30th.
On 30th, yeah.
Okay, thanks.
Okay. So by the time you people can just try installing the things on your laptop and mm, basically try to run just Hadoop FS command. And if you face any problem, just drop an email on mirage@designpathshala.com, or we can discuss our problem in the next class.
In next class, are you going to like, do we need to install everything
Uh,
for
in
next class?
in next class, I'll walk you through the concepts of MapReduce, and I'll explain you how to run the MapReduce code. And that's a 2.5 hour class. So probably at the end of the class, after last half an hour, I will request you to run one MapReduce code. So it's good if you are set up with everything, so you can do some hands-on in the next class.
Okay, let me see if I can get because like I'll be at someone else place, so I'm not sure about the
So
internet or I'm not.
you can try it later on also, and if you face any problem, you can just drop me an email. So, but I'll request you to try it out because if then later on people just become lazy and they would don't try it out. So so I'll ensure at least people learn some basics so that they do not forget what they have learned or what they were learning up in the class.
Yeah.
Okay. And one more thing, please also share your phone number so that if in case I'm not able to join, I'll inform you in advance so that you won't,
Okay.
wait.
Okay. I'll drop you on the email.
Okay, no issues.
Or you can directly call inform to Rupal also. You have her email ID. You can just inform to her also.
Okay, sure.
Okay, then let's meet on Saturday and then we'll see further on. Sure. Then thanks everyone for your time and have a nice day. Good night.
Yeah, thanks, and good night to both of you. Thank you, Miraj.